Good day, my dear students. Your topic for today is quality assurance. So last time, we've discussed about the phases in laboratory testing, and you've learned that there are many factors affecting your laboratory process. Specifically, maraming factors ang nanggagaling sa pre-analytical variables, if you can still remember. So what are we going to do with these variations? With these factors that affects variation. Napag-usapan natin last time, develop systematic workflow, identify critical processes, continuous monitoring. This is what we are going to emphasize in this topic today. Continuous monitoring. Predict accidental events so preparation may be ahead, strengthen defenses, and decrease vulnerability. So lahat ng ito na nabanggit natin, this is all part of your quality assurance. So quality assurance refers to planned and systematic processes that provide confidence of a product's or service's effectiveness. So these are all of the procedures, action, paperwork that take place to be sure that the results given to the physician are accurate. So it involves management, quality management, your quality assurance, ito siya. Sakop niya ang quality control. So, ang emphasis ng discussion natin for this time is actually on quality control. Paano siya ginagawa? And other aspects of good laboratory practice. Remember guys, we are talking about the whole laboratory testing process per se. Quality control is involved only in analytical process. So, meron pa tayong pre-analytic at saka meron pa tayong post-analytic. So, ang quality assurance, yun ang scope niya. Mas malawak kesa sa quality control. So, quality control ito yung mga aims ng quality control natin. To ensure that the right test is carried out on right specimen and right result and right interpretation is delivered to the right person at the right time. So, puro dapat tama. Puro dapat correct. Kasi nga, we deal with accuracy. Hitting the target. So, this is your quality assurance cycle. It involves your pre-analytic, analytic, and post-analytic. So, what are the effects? Just a review. What are the effects of pre-analytical variables on quality of lab testing? Sabi ko nga, last time, 75% of lab errors comes from the pre-analytic. So, analytical phase and post-analytical phase are dependent on the specimen submitted in the laboratory. So, if you could just imagine, no, itong buong steps na to is accounted to the pre-analytic variables and 75% ng variables ay manggagaling dito. So, what are the errors na pwede nating makita? Actually, I believe alam nyo na to, na-review nyo na to sa phases in laboratory testing. So, here are some examples. Next, we go to the analytical phase. This is actually the bulk of our discussion today in the analytical phase, specifically in terms of quality control. How do we carry out quality control in analytical process? So, in analytical process, meron tayong tinatawag na standardization. Remember the reference materials na sinasabi natin? We always have to stick with the standards. In terms of standardization, meron tayong kailangan gamitin. We need calibrators, we need reagents or control materials, and dapat maganda yung test condition natin. So, we need to ensure na tama yung mini-measure ng mga makina natin. So, granting, okay tayo sa pre-analytical, accepted natin ang sample natin, paano natin malalaman if the method is working right? So, just an analogy, how will you know that the calculator is working right? Syempre, i-check mo kung ang ibibigay ng calculator pag in-input mo ang 1 plus 1, supposed to be, ang sagot niyan ay 2, right? So, ganun din sa clinical laboratory. Kailangan mong alamin kung tama ba yung nilalabas nung calculator mo o nung machine. Kapag hindi, ito troubleshoot mo siya. Paano mo siya ito troubleshoot? Kailangan mong i-calibrate yung calculator mo or yung machine mo. Kailangan swak siya dun sa reference na meron ka. So, we will talk about this today. Reliable analytical methods are obtained through careful process of selection, evaluation, implementation, maintenance, and control. So, analytical methods. Yung mga makina pala natin, nag-undergo siya ng very strict and tedious or careful process bago siya pwedeng gamitin. So, before makapasa ang isang makina to be used in the laboratory, it has undergone series of processes. So, selection and evaluation, titignan dyan kung maganda ang performance ng makina. Precision-wise, accuracy-wise, maganda ba yung performance ng makina. And then, after selecting a method and validating a method, i-implement yan. And then, kapag ina-accept na natin siya, meron tayong routine maintenance na tinatawag. Routine testing na tinatawag para malaman natin na nag-work ba ng maayos yung makina natin. So, in routine testing, dito na tayo pumapasok sa quality control. Aalamin natin kung tama ba yung binibigay ng makina. So, a good analytical method or a great analytical method should contain the following characteristic. It should be accurate, it should be precise, it should be reliable, it should be sensitive, and it should be specific. So, definitions-wise, mga kapatid, dapat aware kayo, makikita nyo kung ano ang meaning ng mga ito in your book. In Bishop, they are seen in boxes, even in Henry's. So, just an analogy, gagamit tayo ng dart to illustrate what precision and accuracy mean. So, when we talk of accuracy, we hit the target. So, we hit the target. This is the target. So, as you can see, precision, accuracy dito sa pinaka-last, na-hit niya yung target. When we talk of precision, we talk of reproducibility. We talk of closeness of the values together. So, kapag nirepeat mo ng nirepeat ang isang test using one sample, it should be na paulit-ulit na magkakalapit yung resulta niya. Hindi siya nakascatter. Ibig sabihin nito, walang precision. Ibig sabihin nito, walang precision, pero malapit siya to target. Okay. Now, for it to be reliable, mga kapatid, dapat accurate siya and precise. We will define sensitivity and specificity as we proceed sa topic natin. Okay. To determine how good a given method or test is at detecting disease or condition, the following are used. Kailangan natin itong parameters na to para makita kung tama ba yung binibigay ng makina natin. Diagnostic sensitivity, diagnostic specificity, positive predictive value, and negative predictive value. So, nandito, dapat yung analytical methods natin, meron siyang ganyang criteria, meron siyang ganyang parameters. So, what does sensitivity or diagnostic sensitivity and diagnostic specificity mean? Ito lang ang tatandaan natin. When we talk of sensitivity, ang hirap pala magsulat dito. When we talk of sensitivity, we look at the ability of an analytical method to test the positive patient or the presence of disease. Pagka sinabi naman nating specificity, the ability to classify the negative from the positive. So, titignan nyo lang, pag sinabing sensitivity, positive. Pag sinabing specificity, negative. Para hindi tayo malito. Okay, let's take this for example. These are pregnant patients and these are non-pregnant patients. When we talk of sensitivity, it is the ability of a testing method to detect pregnancy. So in this example, there are 10 pregnant patients. So 10 yan. Doon sa pregnancy kit test ninyo, so for example, this is your pregnancy test, no? Pregnancy test kit. Yan. Sa pregnancy test kit natin, 10 ang pregnant women supposed to be. Pero 8 lang sa kanila ang nag-positive gamit ang test kit nyo. Yung 2 na buntis, hindi siya nag-test ng positive. So, ang tawag sa kanya ay false negative. So, therefore, 8 out of 10. That's 80%. So, 80% sensitive yung ating analytical method. So, is 80% good? Yes, pwede na din, but it would be better if we will get a higher sensitivity. For higher sensitivity analytical methods, mga kapatid, medyo it comes with a price, of course. Next, we have specificity. Pag sinabi naman nating specificity, this is an example of non-pregnant women. Nag-test sila sa pregnancy kit test din. Out of 10 negative women, only 7 tested negative. Yung 3, they tested positive. So, therefore, ang specificity natin ay 70%. Ang tawag sa mga nag-test positive ay false positive kasi hindi naman talaga sila buntis. So, the sensitivity is 80% and the specificity is 70%. Yun yung gusto niyang sabihin. Next, ano naman yung positive predictive value? When we talk of positive predictive value, PPV indicates the probability of being pregnant if the test is positive. Gaano ano yung probability na magpa-positive yung mga pregnant kapag ginamit mo itong test method na to. Tapos yung specificity naman, negative. Okay? So, parehas lang sila. Why are we doing this? Bakit natin kailangang malaman kung maganda ang performance ng isang analytical method? Para, and why do we need quality control under quality assurance or under analytical method? Bakit kailangan natin siyang i-monitor using control? It is to detect errors, and there are only allowable errors. Specifically, there are errors in imprecision, and meron tayong errors in accuracy. So what are the errors in imprecision? What are the errors for precision? We have, this is determined by, imprecision is determined by repeated analysis. And then inaccuracy is determined by recovery study, interference study, and comparison of method. Mga kapatid, kung mapapansin nyo to, sabi niya study, study, study. Kasi, kailangan nating makita ang error using statistical method, statistics. So here are some errors defined for you. So please do have time to memorize them and understand them. So what's the difference between quality assurance and quality control? Sabi ko nga sa inyo, quality assurance, quality control is under quality assurance. Quality control is just confined with analytic phase of testing. It refers to the measure that must be included during each test run to verify the test is working properly. It aims to ensure that the results generated by the test are correct. Ayan. So, pag-usapan natin kung ano ang ibig sabihin ng quality control. Sabi niya dito, it must be included in each test run. So, ibig sabihin, per run mo dapat ng specimen, for example, for glucose testing, may sample ka for glucose testing, meron ka ring kaakibat na control. Ayan. So, yan ang ibig niyang sabihin. Para, just like the pregnancy kit test, diba kung mapapansin nyo, ito yung test, ito yung control. So, dapat, ito yung basis ng test mo. Ayan. For those of you who've already seen a have seen a pregnancy test kit already, ganito siya. Ganito ang itsura niya. So what is, paano ba ginagawa ang quality control in the clinical lab? You have to select high quality controls. When we talk of controls, we refer to reagents. There should be at least 20 control values over a period of 20 to 30 days for each level of control. Perform statistical analysis, develop Levey-Jennings Chart, monitor control values using Levey-Jennings and Westgard rule, take immediate corrective action if needed, and record actions taken. So this is the process, no, of your quality control. Hihimay-himayin natin yan para mas maintindihan natin. So why do we need at least 20 control values? Sabi ko nga sa inyo, errors are measured statistically, actually. So, in order for it to be statistically significant, kailangan niya ng at least 20 na values. So, usually, in the clinical laboratory, yung isang buwan, 30 days, ginagamit nila to detect the performance of a test. So, sa isang buwan. So, huwag kayong matakot kasi meron dito perform statistical analysis. Tuturuan ko kayo kung paano mag-perform nito at saka kung paano gumawa ng Levey-Jennings chart. We will actually do this on a separate video. So, before we proceed, let's just be familiarized with the following. Calibrators, or ating standard or ating reference material. It has a known concentration of the substance being measured. So, anong ibig sabihin nito? For example, this one. This is protein calibrator. This is for glucose calibrator. I cannot see this one. So, ibig sabihin, per test, meron tayong calibrator. Meron tayong standard. It is used to adjust instrument, kit, test system in order to standardize the assay. Meron tayong basis. It has a known concentration. Ibig sabihin nito, alam na, it's not written here. This is calcium. So, ang value ng calcium, dahil sabi nga natin known concentration siya, is 464 micromoles per liter. So, this is your basis for calcium. This one for protein, it's something 5.6 milligrams per liter. So, I don't know kung ano pang number kasama nun. So, sabi natin, it has a known concentration. Alam na dati pa kung ano ang value ng mga calibrator. This is not a control. Tandaan natin, this is not a control. What are controls? So, these are controls. Ang control natin, ideally, it should come in 3. Isang normal control, dalawang abnormal control, abnormal low and abnormal high. So, what are control? Controls are similar to your test specimen. So, for example, kung serum ang sample mo, dapat serum din yung control mo. Serum din ito. Okay? They should be dapat small quantity ito. They should be stored in small aliquots. So, this one is, I think, 5 ml lang. Ang ibig sabihin ng small alicot, dapat kaunti lang sila. Hindi sila madami. Kasi, kapag marami yan, prepared yan in large quantity, prone siya sa deterioration. So, ideally, it should last 1 year. Often use biological material considered to be hazardous kasi nga same siya as your test specimen. So kung serum siya, serum din. Sufficient material from same lot number or serum pool for 1 year's testing. Okay. This is very critical. Dapat daw pare-pareho sila ng lot number. So sabi ko kanina, 5 ml lang ang isang alikot. So, ibig sabihin, sobrang konti lang niya. This one, pag once na ni-reconstitute mo, when we talk of reconstitution, naka-lyophilized form kasi ito, powdered form. Magmi-mix ka ng water para maging 5 ml, para maging liquid siya instead of powder. Parang gumagawa ka lang ng nagre-reconstitute ka lang ng antibiotic, yung powdered form nilagyan mo ng tubig, tapos magiging liquid siya. Reconstitution ang tawag natin doon. Now, kapag once na nirecon mo na siya, ang mangyayari is within 3 to 5 days, magde-deteriorate na yung specimen mo. Although this can last for 1 year, kapag naka-lyophilize siya, kapag once na na-recon mo na siya, magde-deteriorate na siya. So, hindi na siya magandang gamitin, mabilis na siyang mag-expire. So, dapat, pare-pareho yung lot number niya. Ma'am, paano yan? Pag naubos yung 5 ml, magbubukas ako ulit kasi dapat 30 days run, diba? Every day dapat nagra-run ka or 20 days. Every day dapat magra-run ka ng control mo. Sa isang box ng control, sa isang box, pare-pareho dapat siya ng lot number. So, kapag nag-order kayo, again, sa manufacturer, yung box na ito, i-order nyo ulit siya with the same lot number as yung pinurchase nyo ulit. Kasi, para hindi na kayo mag-recalibrate. Hindi nyo na kailangan i-recalibrate yung machine. Otherwise, ang mangyayari dyan, mag-fluctuate yung values ng control ninyo. Mapapansin ninyo, may, oops, there's something wrong. Later on, maiintindihan nyo to when you do hands-on. It may be frozen, freeze-dried, or chemically preserved. It requires very accurate reconstitution if this step is necessary. Ayan. Ito na yung sinasabi ko, it has to be reconstituted. So, ano yung mga control materials natin? It can be assayed, unassayed, or homemade. Ito, mga kapatid, manufacturers ang nagbibigay nito. And ito ay pwede nating gawin. Pwede nating i-prepare sa laboratory. So, how do we prepare a pooled sera? When we talk of pooled sera, in your clinical laboratory, you will often have a patient that has high value. It has those that has normal values and those that have abnormal low. So, ang gagawin mo, iipunin mo lahat ng high, iipunin mo lahat ng normal, at iipunin mo lahat yung abnormal. Sila na ngayon ang gagawin mong control. Pwede mo silang maging basis since you already know their values. So, alam mong mataas ang value nila, alam mong normal, and alam mong abnormal low. Ang hindi maganda dito pag ginamit natin, of course, this came from patients. So, general rule in the clinical laboratory, treat all specimen as potentially infectious. Siyempre, biohazardous yan. Kaya mas maganda pa rin na bilhin natin siya sa manufacturers. Okay. Data analysis. Dito na tayo papasok sa ating simple statistics. You need at least 20 data points. Nasabi na natin yan kanina. We have to calculate the mean, standard deviation, coefficient of variation, and determine the target ranges. In this session, in this topic, we will only be tackling about mean and standard deviation. Yung coefficient of variation and ranges, hindi na muna natin masyadong i-discuss. Although na-touch nyo na yan sa statistics ninyo, because ito lang kadalasan ang ginagamit natin. Ito yung pinaka-ginagamit natin sa lab. And then, develop Levey-Jennings Chart. I will teach you how to do this also. So how do we measure variability? Or we can measure actually errors from this one. Make sure that there is procedural variation. When we talk of procedural variation, dapat magkakaiba ang magte-test. Hindi lang iisa ang gumagawa ng control. Dapat magkakaibang araw. Then, hindi lang isa-isang araw magko-control ka. Kinabukasan, hindi na. Dapat everyday. Pwede ding 3 times a day kaso masyadong mahal. So, usually, ang practice sa laboratory with all controls are done in the morning. So, wala munang test. Titigil lahat ng test. Ang gagawin is i-control muna yung machine. A certain amount of variability will naturally occur when a control is tested repeatedly. Variability is affected by operator technique, environmental conditions, and the performance characteristics of the assaying method. The goal is to differentiate between variability due to chance from due to error. Sabi ko nga sa inyo, magde-detect yan ng error. Okay, so here are some common sources of measurement variability. So this is actually taken from Henry's. So take time to memorize and understand this. So let's look at kung paano mag-calculate ng ating mean at saka ng ating standard deviation. Let's look at basic QC statistics. So first, we need to measure central tendency. We use mean, median, and mode. Pero hindi natin ginagamit ang median at saka mode. We use mean. And then, we measure dispersion. We use SD, CV or coefficient of variation, range, and variance. So, this is an example. Hanggang 11th day run lang tayo. These are control values already. So, these are your control values. Sabihin natin this is abnormal high glucose values. Pagpalagay natin na abnormal glucose control siya. Ito yung mga values after 11 days of running your QC. Ito yung nakuha natin. So, alam naman natin kung paano i-measure yung mean. Mean, so, summation of X divided by the total number of tests. So, summation of X, that is your mean. So, ito siya, 2,200 pala milligrams per deciliter divided by 11. So, ang nakuha natin ay, so ang ating mean ay 200. So, that's just an example. We will look at this further on a next video. So, measurement of dispersion and variability. So, nakuha na natin ang mean. Our mean is 200 milligrams per deciliter. Now, we will look at the measure of dispersion. Bakit natin kailangan makita ang measure of dispersion or variability? Kasi ipa-plot natin yung points using a normal distribution curve or a Gaussian curve. So, gaano ba kalayo ang control values from the mean? Yun yung ibig niyang sabihin. Kaya tayo merong central tendency. Gaano kalayo yung values, dispersion ng values from the mean. So, we use standard deviation. So, standard deviation is summation of X. Summation of X minus the mean squared over N minus 1. So, yan. Sabi ko kanina sa inyo, we need this one. We need to know the mean and we need to know its dispersion gamit ang standard deviation para ma-plot natin ang normal distribution curve. So, in a normal distribution curve, this is your mean. This is your mean. In a normal distribution curve, dapat symmetric siya. Kung anong meron dito sa left, yun din ang meron dito sa right. Symmetric nga siya, diba? It should have a bell-shaped curve, and yan. It follows a 68, 95, and 99.7 rule. Ano yung ibig sabihin ng 68, 95, and 99.7 rule? Ibig sabihin nito na 68% ng values mo or ng control values mo belong to 1 SD. And tapos 95% ng values mo belongs to 2 SD and yung remaining na ito, yung remaining 5% belongs to your 3 SD. So, okay. This will be explained further. Rule in quality control. In general, laboratories use +2 SD criteria for the limits of acceptable range for a test. When QC measurement falls within range, there is 95.5% confidence that measurement is correct. Only 4.5% of the time will a value fall outside of range due to chance, or more likely it will be due to error. Ayan. So, if your points or if your control values fall within the range of 95%, ibig sabihin nito, yung control values mo acceptable. Okay? Those that fell outside 95%, usually, ito na yung nagkukos ng error. So, kung dapat yung points mo nandito, they belong here. Your points should be within this one. Control values or control points. Okay? So, let's proceed. Remember, dapat control values are within 95% criteria. So, how do we monitor our QC data? We use Levey-Jennings Chart. We plot control values each run and make decision regarding acceptability of the run. Monitor over time to evaluate the precision and accuracy of repeated measurements. Review charts at defined intervals. Take necessary action and document. Okay, so we will do this step by step mamaya. So this is an example of your Levey-Jennings chart. So in your Levey-Jennings chart, ito yung time natin or days. Ito naman yung control values natin. Ito yung mga nakuha nating result. So usually, sabi ko nga sa inyo, within 30 days, ginagawa natin ang monitoring. Kung mapapansin nyo, this solid line represents your mean. Itong broken line represents your 1SD, positive 1SD. Ito is negative 1SD. This one is positive 2SD. And this one is negative 2SD. We will explain that further when we go to the next video. Ideally, control values clustered about the mean with little variation in the upward or downward direction. Ganito daw dapat siya. Ganito lang siya. Supposed to be. Imprecision means a large amount of scatter about the mean, usually caused by errors technique. So, looking at the graph pa lang pala, malalaman mo kung ang error niya is imprecision, malalaman mo kung ang error niya ay inaccuracy, or is it a random error. When we talk of inaccuracy, makakakita ka ng trend or shift. We will define that later on. Usually caused by a change in testing process, or random error. It has no pattern, usually due to poor technique, malfunctioning equipment. Mga kapatid, dito sa poor technique, it includes human error. Usually, pipetting technique, mga ganyan. So, what is a trend? Meron tayong dalawang trend. It can be upward or it can be downward. Upward, ibig sabihin, pataas yung points natin, pataas yung values natin, no? Pag sinabi mong downward, pababa siya. Ayan. So, supposed to be, the ideal is paganyan siya. Kaya lang, sa part na to, makikita mo agad na trend siya, downward trend siya kasi pababa siya ng pababa. Usually, downward trend is the cause of contamination of reagent, standards are too concentrated. Ayan. When we talk of shift, ito naman, points are scattered either sa taas or sa baba. So, dapat kasi, kapag maganda ang control natin, it should be crossing the mean. Kaso ito, kapag sinabi mong shift, either yung points natin ay concentrated lang on one side or concentrated lang siya on the upper side. So, here are the reasons kung bakit nagkakaroon tayo ng shift. And then we have outlier. Ang mga outliers ay, of course, alam niyo naman kung anong ibig sabihin ng outlier. Kapag ikaw ay average person lang, sasabihin mo sa mga geniuses at mga na-perfect ng exam, sobrang outlier nila. So, ang ibig sabihin naman ng outlier dito, lumabas na siya sa 3SD. Remember, uulitin ko, ang acceptable limit lang is within 95% confidence interval. Kapag ka lumabas ka na dyan sa points na yan, ibig sabihin there's something wrong. There's an error to it. We call this one an outlier. Okay. So we already know kung paano tignan ang Levey-Jennings chart. Ang Levey-Jennings chart natin ay coupled with your Westgard Multirule para ma-rule out natin kung performing well ba talaga or in control tayo or of control tayo. Westgard Multirule or Westgard rule is a combination of decision criteria or control rules. Ayan. So, ito siya. We have 1-2S, 1-3S, 2-2S, R4S, 4-1S, at saka 10X. So, tignan natin isa-isa. When we talk of 1-2S, ito lang ang tatandaan natin. So, this is, for example, your, ano ba to? Levey-Jennings chart. This is your positive 1S, positive, ito yung inyong positive, 1S, ito yung negative, 2S, positive, negative, sorry, negative. This is your 3S, negative. This is your 3S, positive. Ayan. Pag sinabi nating 1-2S, 1 control value exceeds 2SD. Nasaan ang 2SD? So we have dalawang 2SD, positive and negative. So 1 control value daw exceeds 2XD. So you can see it here or you can see it here. So this is not an error actually. This just serves as a warning. So let's look at 1-3S. 1-3S. So 1 control value exceeds 3SD. So for example, this is your 3SD. This is your 3SD. This is your mean. Nandito na sila. Remember the outlier? Sila yan. Next, we have 2-2S. 2-2S. 2 control values exceeded 2SD. So, for example, this is your mean. This is your 1SD and your 2SD. So, 3SD. Ito. So, 2 control values exceeded 2SD. Yung kanina, 1-2S, ngayon, nadagdagan pa siya ng isa. So, first day, second day. Okay? So, first day, sabihin natin, this is your third day, fourth day. Ayan. So, 2 control values exceeded 2SD. This is an error again. And then we have R4S. When we talk of R4S, for example, ayan, yung value nito, it exceeds 4 plots. So, for example, ito yung mean, 4 na points ang pagitan niya. Ayan. So, this is your R4S. Usually, this is due to random error. Then, we have 4-1S. When we talk of 4-1S, so this is your mean. 4 na points daw. 1, 2, 2, 3, and 1, 2, 3, 4 is confined only sa 1SD. Ayan. So, this is your R4S. 1 4S. 4 1S, sorry. Then we have 10x. 10x, ibig sabihin, dito lang siya naka-confine. Ayan. If this is your mean, dito lang siya sa isang side naka-confine. Just like your trend, just like your shift. Ayan. So, ayan. Ito yung diagram kung i-accept natin or hindi. The only thing actually that you will accept or which will serve as a warning from Westgard rule is 1 to S. Wala nang iba. The rest, kung meron kayong nakita, you have to reject it because it's already out of control. Remember, this is just a warning. It's not an error. So what are the systematic errors? And dito siya. What are the random errors? Na yan, nandyan siya. So I will be discussing to you kung paano gumawa ng quality control chart, kung paano yung computation on the next video.